go. Okay, guys, we're going to get started real quick. Yes? This one. We're going to get started real quick. Thank you guys for being here today. I am just going to talk briefly about our upcoming events. On November 4th, we have the Fin Feather Fur Food Festival. It's going to be at Aspen Ranch in Edmond. If you are not already signed up as a cooking sponsor and would like to participate, let me know this week because I'm going to be starting preparations for signs and stuff, so I need to know this week. Currently, our cook teams are New Park, Schlumberger, Hoover Group, KSW, Piper, Genesis. We've got about 12 here. Washita, no, it's not them. Helmrich and Payne, Baker Hughes. We are having live entertainment this year, so last month I made a plea for sponsors, and we ended up with plenty of sponsorships for live entertainment, so that is going to be something new this year. And most of us that are in the room are in sales, and so what I would like for you to do is invite your customers, please. Send them a note. It's a free event. It is the trailers will be set up in the parking lot. They are bringing the food inside. They have to cook a fin, a feather, or a fur. They are almost like exhibit booths where you walk around. Your wives can come. You can bring your kids. I don't have a lot of kid events, but please come. Invite your customers. It is going to be a great networking event. And just keep in mind, November 16th, we have TTS Drilling that will be speaking here. January 18th will be Richard Spears. It is currently here, but I am looking to see about making it an evening event, so I will be in touch with that. February 15th, Wild Well Control will be speaking well control trends and case histories from unconventional basins. The Bass Tournament will be April 1st and 2nd. And Mike Avery is in charge of that, and he wanted me to let all of you know he will be starting asking for sponsorship soon. And then we're going to do something a little different this year. September 14th is going to be our symposium. It's usually in February. We felt like by September, hopefully, the world will be a little bit more normal. And we're going to have that symposium again in Norman. So if you guys have any questions for any of our events or any suggestions on how to get more engineers in the room or at our events, let us know that as well. So I'm going to pass it over to Matt Little. He is our AADE treasurer, and he's with Tag Drilling Motors.
Welcome everyone, thanks for coming. I'm here to introduce Dustin Lyles with Tourx. He's the VP of Technology. He's spent his entire career in the energy industry, specifically focused on oil and gas drill bit services. Dustin's passion for problem solving and data analytics drove his rapid career progression across international and domestic markets, and various roles related to product development, engineering, and technology. Most recently, Dustin championed the development of Torx drill bits' patent-pending automated metrology lab, known through the acronym AML, that has fully digitized the tedious but extremely critical evaluation process of dull drill bits. Dustin holds a BS from the University of Oklahoma and has multiple granted and pending patents in the areas of drill bit related technologies. Dustin also currently serves in an advisory role for the International Association of Drilling Contractors initiative to upgrade the IADC bit grading system. Now I'm very interested in this. I think taking a lot of subjectivity out of bit grading will only help everyone, and it's cool that you're at the tip of that spear. So welcome, Dustin.
Thank you very much. All right, thank you all very much. Can everybody hear me okay? Good? All right, we got a mic if we need it, but I don't think we do with too small of a room. So thank you for the opportunity to speak today. We're excited to share some of our new and innovative technologies here at Tourx and tell a little bit about our company. So what we're going to be talking about today is Tourx Drill Bits Automated Metrology Lab, or better known as AML, and we'll dive right in. So not going to get into this much, but just a little background on Tourx for those of you who may not be familiar with our company. We have been around in the drill bit space for about 60 plus years in a number of different names over the years. We originally, the Wakeman family was the original owners, going back to the 1950s and 60s, and we were recently, though, in January of 2018, acquired by a private equity firm by the name of Interval Capital. They recently changed their name to Amberjack. This is the same firm that at one point owned Volterra and then sold them later on. We are a manufacturer of PDC drill bits in both matrix and steel body. We have approximately 60,000 square feet worth of manufacturing and repair space between our manufacturing plant, which is down in the Woodlands, Texas, as well as our headquarters and repair facility, which is up in Norman, Oklahoma. And home to AML is actually in our repair facility, and we'll kind of get into the reasons why within the presentation. So the AML lab itself is in our headquarters there in Norman, Oklahoma. We have a long-standing partnership. We originally started kind of in the Midcon market, predominantly on the drilling side with King Dream roller cone bits, and since brought that into PDC bits as the drill bit market evolved and that encroachment of PDCs took over. But we still have that partnership with King Dream drill bits, and we're currently the market leader in the completion space with our roller cone completion bits, and have a patented drill bit technology in that space as well. We are one of only 7 companies to hold a deep leach cutter license. We acquired that in late 2019, which was a game changer for our company as a whole in the markets that we could participate in, for any of you that are familiar with that technology. We have sales offices in all major U.S. land markets as well as some international markets, and we are continually expanding. This bottom here, the chart down at the bottom right, kind of shows the rapid progression of Tourx drill bits over the past approximately 3 years. That equates to about a 3.6 times increase in market share that we've been able to enjoy and experience within the U.S. land market. A lot of that has to do with what we're talking about here today, the company's culture and the technology that we've been able to deliver. Getting into the company's culture just real quickly, at Tourx, our vision is to achieve more for our family, employee, customers, shareholders, suppliers, and communities. We drive to do this each and every day by being and building the bit company the industry deserves through performance, trust, and innovation. Within this, what allows us to meet and achieve all of those goals is the responsiveness, collaborative, data-driven, knowledgeable. You're going to hear me talk a lot today in this short period of time about data and the value of data. But that knowledge sharing and that ability to interact with our customers and our suppliers to increase everybody's knowledge to advance the drilling industry and ultimately reduce cost per foot. All right, so getting into Tourx's automated metrology lab. So a little bit of background, kind of the innovation in new technology is always driven by a problem. The problem that we faced and have faced for decades as drill bit providers is that a lot of the knowledge that we gain and the insight that we get as we optimize drill bits is gained by evaluating what you see here as a dull drill bit, the amount of wear and tear. Historically speaking, this has been done by the industry standard IADC dull grade, which, as was mentioned, we're part of the initiative to upgrade that project. That'll be released later in 2022. I think the first update will be actually in March of 2022, but we're taking part in overhauling that. And the reason being, it's an archaic system that has been around and was originally developed for roller cone drill bits. Our industry deserves a better solution than that, is what we believe. And so this is what drove us to develop the automated metrology lab. Traditionally speaking, outside of the IADC dual grading code, drill bit engineers such as myself would spend a tremendous amount of time sitting down and evaluating dull bits. So say we have out in granite wash, whatever, I know there's not much drilling out there, but just to keep it local in Midcon granite wash laterals, say we've ran hundreds of drill bits, we would literally want to sit down and evaluate all of those dull drill bits because they're telling us a story. They're telling us, it's kind of a fingerprint, if you will, of what's occurring down hole. It's the best indication of what that drilling environment is like down hole, is by evaluating that dull drill bit and letting it tell us what type of failure and the severity or quantification of the failure mechanisms. So the question became, what if we could somehow systematically remove the subjectivity. It's not a drill bit engineer. It's tediously going through and evaluating individual pictures of dull bits and trying to assign dull grades to them. What if we could actually let each and every one of those drill bits speak to us and tell us through data, digitized data, what they experience downhole into a database system so that we can extrapolate that and better understand on a massive scale in a matter of minutes what all these drill bits are telling us. So that led us to obviously move beyond the IDC bill grading code to what we call AML. So AML stands for Automated Metrology Lab. Automated because we use an automated robotic system as well as an automated metrology inspection process to evaluate each and every drill bit that Tourx runs. So every single drill bit that goes downhole for our company returns to our repair facility and goes through this process. Metrology because we're using metrology grade technology to precisely measure the amount of wear and tear on every individual cutter on each and every drill bit that we run. Using this patent pending technology, we are laser scanning every dull bit to collect a database of wear data for every cutter on every drill bit, which can be used to fast-paced product development and lead to more scientific, data-driven optimization strategies from a drill bit design perspective. And again, we've got a small crowd in here today. You guys feel free if you have any questions as we're going through this, stop me and ask questions. But. So this is the cell itself. So how it works and what this looks like is that, again, we've got the metrology station here. This is where a metrology technician would be sitting. We have a drill bit there on a rotary table with a robotic arm with a metrology grade optical laser scanner that scans and produces point clouds of basically producing a digital twin or a digital dull, if you will, of that drill bit. Got a 24-core grade engineering computer there that is capturing that data and helping to convert that into a 3D mesh file. Once a bit comes into our repair facility in Norman, every single bit is first cleaned and then moved over to the cell itself, loaded and specifically placed and positioned from an alignment perspective systematically every time in the same alignment methodology. There are targets that help to create basically a grid of this entire space where that dull drill bit is. So as the lasers are going around, the drill bit is spinning and we know where every port position of the drill bit is, and we're capturing that contour to replicate what you see there on the right, which is the point cloud file that later is converted into a mesh file. This all occurs within a matter of 4 to 5 minutes. It was very important for us to make this rapid because it needs to be scalable. We can produce, right now we have one cell, but we could add on, and this allows us to sustain that growth and have that scalability to our business. After the drill bit is scanned, the mesh file, what we refer to as a mesh file, which is just triangulated point clouds, so basically a 3D model of the drill bit, is coupled and aligned with the CAD. So we mesh it or align it to the CAD file, and then we're able to perform a number of different metrology inspection procedures using features and programmatic scripts that run within our process. What this does is it goes in and it identifies each and every cutter on the drill bit of interest to us. We can apply color mapping so you can visually see that deviation, whatever degree of wear and tear has been sustained on the drill bit, as well as, like you're seeing there in the top right, those annotations show you the individual, what we refer to as DAR, or diamond area removed. So precisely down to 0.003 of an inch accuracy, how much of the diamond was lost on each and every cutter on the drill bit that's run. This inspection process is done offline, basically on a host server. So as soon as the bit's scanned, the mesh file is moved to our server, and this allows us to load the next bit scan while that inspection is going on. The inspection takes about anywhere from 12 to 15 minutes, depending upon the size of the bit and the number of cutters, and then automated reports are generated so that our drill bit engineers, as well as our repair technicians, have this rapid digital feedback loop that's driving and helping aid in the decisions that are being made at every portion of our business.
does that analyze the body, so if you have erosion or any kind of failure with the body, does it analyze that or just on the cutters?
Great question. So actually, it does. I don't have it on this slide. Well, kind of here. So you can see that deviation mapping, the bottom right. We do two different, there are two different systems, kind of avenues to our inspection process. One is to really focus on the wear and tear on the cutters, but then we have another avenue by which we can run analysis on the drill bit body itself. And so that is where we can gain insight and help to validate, like CFD, computational fluid dynamics. We've used this data to look into that and further validate our models or tweak them based off of what we're seeing in real life environments. As you all know, a model is only as good as how it can actually replicate what's occurring in real life. And so now we have a system by which we can do things like evaluating the wear and tear to the body itself as well.
I noticed in the images you showed us, you're only showing primary cutters. Are you guys not concerned about the backup cutters, or does it not look at those?
Another good question. It's not that we're not concerned, but this project in and of itself was kind of an elephant to eat, if you will, and we had to eat it one bite at a time. That's actually part of what we refer to as our kind of phase 4 scope. We're continually adding to this system, and one of those additional components is that we will be quantifying wear and tear on the TCIs for depth of cut control as well as backup cutters. So that is in the future, we're just not there today. It's just due to the complexity of, we want everything to be automated. That being said, we have had customers that said, hey, I want to understand exactly how much wear. What is the depth of that groove on the TCIs and the cone of the bit that are helping to control my tool face? What does that look like? We can go in and it just requires one of our metrology technicians to manually pull the bit up and do it. Everything I'm showing here is 100% automated. We literally do not touch it. It goes from being scanned to producing results. So we can evaluate wear and tear on backup cutters, TCIs, gauge pads, any component of the drill bit because we have that 3D model. It just is somewhat of a manual process to do those. So, but we do a lot of that actually. It's just all right, moving on into so the AML process overview and analytics. This is where the real value from AML comes, is this holistic, large-scale, big data kind of analytics approach. So within AML, we currently have approximately 3.2 million data points in what we call the HERD, or heuristic encyclopedia of tool characteristics. And what that is a data set, a composite data set. So every bit is scanned, as I said, we automatically push out results on every individual cutter. It goes into this database. Our engineers have instant access to pull this up and monitor wear trends on different applications, different drill bits, even different operators or different rigs. You can somewhat subscribe to different areas so that you know and get continual feedback into what type of wear and tear, what trends we're seeing within that wear and tear. We currently have within this database approximately 1,900 runs. Early on when we first started, I'm an old school data analytics guy, more Excel based. I quickly realized Excel was not capable of handling data of this magnitude. So our drill bit engineers now today, many of them are trained in statistical analysis and using statistical analysis software, as well as we're moving into machine learning and AI to better understand those underlying relationships. It's just with this magnitude of data, we're trying to drive and better see, how do the complex relationships of back rate, profile, exposure, as well as your application and operator and drilling parameters all tie in together to equate to the trends that we're seeing on the wear and tear of that drill bit. So it's very advanced, and it's something that's still a continual work in progress. We're learning each and every day, and with each step we take, we're introducing new technologies and new models by which we can evaluate these the individual drill bits. A quick little graphic to help kind of display what we're talking about here is, one of the biggest things that we deal with. Everybody talks about data and the digital oil field and the digital age, data. We suffered the same thing that a lot of companies suffer, honestly. When we got all of this data initially, like I said, we were trying to figure it out within Excel. What is it all telling us? How do we create value from all of this data in a systematic manner? And so we went through this process that I believe this little, these are called, what are they called? Infographics. The Lego infographic. This one's kind of renowned and pretty famous, but basically that data goes through a process of sorting. You get data, it's jumbled up, sort it, arrange it, present it visually, and then eventually the most powerful data, and the reason that everybody in not just our industry, but in all industries are so interested in data is because ultimately it should tell us a story. It needs to help us. Each and every one of you, no matter what position you're in, you're making decisions each and every day, right, about what you do to create value for your company. We at Tourx believe that we want our people enabled with data to help them, not to replace them. And we know that without the data alone, without context, doesn't give us everything we need. But your experience and your context added to that with data to help drive you and help inform your decisions, allow you to make better decisions each and every day. And it's all about bringing that data in and running it through models, cleaning it, and then putting it into a position where we can tell a story with it. And that's where our machine learning models and data analytics and statistical analysis models help us to tell that story. We want to know the story of each and every drill bit that we run in any given application so that it can influence the decisions we're making today and tomorrow and the next day. So within AML and the outputs, we obviously use this data to feed our digital feedback loop and continually optimize our drill bits, but we also had very early on customers reaching out to us and saying, hey, we need that data. We want that data to feed our systems. We have our own dashboards. We want this data to be fed straight into our system so that we can better understand when we change drilling rig or application or parameters, what effect does that have on the wear and tear of the drill bit. So this is an example of a CSV file where we can actually push this through CSV files or through a web API directly to the operators so that as an operator, you can gain insight from each and every drill bit, and not just a dull grade, but literally every single detail about that drill bit, and put that into their own internal databases. Spotfire, one for instance, and then a lot of the bigger companies have developed their own. We can also curtail these and have done so to meet the customer's need. Obviously, still, this doesn't completely replace the 2D vision perspective, and so we actually have a new system that we'll be developing, or that it is in development and will be deployed in early Q1 of 2022, by which we will couple this with an automated 2D vision system. But what you're seeing here is just, again, the annotation showing you the exact diameter removed on each and every cutter in a visual as well as graphic or tabular format. It also automatically produces gauge diameter. A lot of our operators and directional companies, probably got some directional guys in the room, a lot of focus on drill bit gauge design, tapers, offsets, you name it, links. Everybody is highly interested in this, so we're currently working with a lot of our customers to do studies to really better understand what is the amount of wear and tear and how does that progress across the length of the entire drill bit, and what does that tell us about the forces that are being applied on that drill bit given the different rotary steerable systems or the different traditional bit housing systems that they're being run on.
Have you been able to integrate any parameters or real-time data coming off baseline or cloud code? Or is it like eating an elephant?
Yeah, that's something that we have experimented with. I'm not quite ready to present on it, but we are doing some studies right now. A few operators we have EDR data, obviously, to a lot of our customers, and that's kind of something we usually work on customers with on a one-to-one basis, though. But it is very interesting because that is part of that I use the term digital feedback loop, but basically, if we have your EDR data, we're able to analyze that and see as you pull the multitude of levers, whether it be RPM, weight on bid, flow rate, so on and so forth, what effect is that having over time on all of the drill bits that you're running, and trying to basically find that happy medium there, if you will, and identify those KPIs, those key indicators that show the strongest correlation between your drilling parameters on the rig versus the wear and tear on the drill bit. Yeah, that's actually a pretty interesting one. That's one that we've done some statistical analysis methods, but we're relying kind of on machine learning because that's a big data set in and of itself that we're adding to ours, so it gets pretty complex pretty quickly. This is one of the standard charts that a lot of our customers prefer and request, which is basically just the diamond area removed by cutter position or cutter number across the profile of the bit, as well as compartmentalizing it into the IEDC dull grade and then what we refer to as the bull grade, which gives you the exact diamond area removed on cone, face, and gauge of the drill bit. And that's appears to be pretty similar to where we're kind of going with the new IEDC dull grading system that should be rolled out sometime next year.
How does the software handle spalls? When it's looking at diamond area removed, because normally a spall is going to occur between the leached and unleached diamond. And so unleached diamond is really not diamond at all as far as cutting mechanics goes. So is it looking at that relationship, or is it just, no, we've lost X amount of diamond and that's it?
So we can actually change the parameters, and we do this to evaluate shallow spalls versus deep spalls. I would say, from our perspective, I mean, if you've lost, even if it is a shallow spall, it's still diamond. It does have cobalt as your cobalt infiltrated within the lower layers. It's just a cobalt-free zone up there on the shallow spalls. But we see that, though, as the beginning of wear progression. So our standard evaluation for diamond area removed is to look at a very shallow level, like 10 thousandths of an inch. And if the spall progresses past 10 thousandths of an inch, we say diamond area removed, yes, and check that box. But in the background, we are able to run and say, evaluate that based off of 10 thou, 20 thou, 30 thou, and tell me the depth of those spalls, which also gives us better insight to working with our cutter vendors and helping them to better understand the failure mechanisms that we're seeing. Yeah, good question. That's the Metrology software, though. That's one of the things that's been it's been daunting to learn. It's just like a lot of your, any softwares out there. They can do anything under the sun. It's just a matter of learning how to do it. But very capable to perform a lot of different analysis. So, and then this is one of our other standard kind of dull grade reports, is a reporting system back to the end users. So kind of in recap, and we'll go into a couple of case studies. Aml Benefits, we say getting to 1 bit faster through increased speed of learning. So this is all about, again, creating knowledge and teaching our people and enabling them to make better decisions to get our customers to what we refer to as 1 bit, which is basically the best drill bit, the optimal drill bit for their given application. We believe whoever's learning the fastest is typically winning, and so it is our goal to leverage this technology to continually accelerate in our learning. As well as a rapid digital feedback loop for cutter vendors. One of the biggest things that we've realized, advantages to this, is that cutter vendors historically see very small portions of the performance on their individual cutters. If they have a project going on with a specific bit company, then they'll get to see dull pictures and get data back. But with this automated system, we're literally able to give back 100% of the data for every cutter that is run downhole in a Tourx drill bit, versus what they estimate at typically 1 to 3% of the data that, the cutters that they run, they ever receive any data back on that holistically. So that has created a new dynamic for cutter development and partnerships with our cutter vendors, which is obviously a critical component to drill bit performance.
You track those by the batch, or they serialized?
They are not serialized at the moment. They are batched, by lot number. So we do track, and depending on the cutter vendors have different lot numbers or batch sizes. But yes, we are able to trace within our QA/QC processes, as well as repair and cutter maps where each individual cutter is or lot. So if there ever is anything of concern, then we can quickly identify where those are, as well as run the algorithms to tell us, hey, if you see anything trending with lot number, definitely key in on that and, throw up a red flag that we need to drill down there. And that question, that kind of leads to the next bullet there, advancing drill bit laser scanning technology beyond traditional quality assurance applications. Obviously, we are API and ISO certified and have all of our checks and balances in place as far as QA/QC. And the scanner itself, this automated scanner, that's the kind of traditional mechanism. So we are able to use that to evaluate coupons for manufacturing and to dial in on our manufacturing tolerances. But that's the more traditional method of what this has been used for historically speaking. We've taken it beyond that into a realm now where we're evaluating the wear and tear on the individual drill bits, which took a more custom approach to that. It took a more custom approach than an off-the-shelf type solution would offer. And then quantified forensic dull grade reporting, as we reviewed there, that digital feedback loop for us as a cutter, as a bit designer and bit optimization company, as well as our customers. And then more scientific VHA and parameter recommendations driven by hard data. So again, as we were talking earlier about changing parameters, but what if you change your automatic driller? What if you change your individual VHA components? What effect does that have on the drill bit? Rather than somebody sitting back and saying, well, I feel like we probably had a little more damage on drill bits over time as you went from this system to that system, we can assign very specific and very precise quantified data on the exact amount of wear and tear. Was it favorable? Was it less favorable from a drill bit perspective? The lifespan of that drill bit. And so that's kind of the same with the assistance with new technology implementation. It's obviously critical that we understand the drilling system as a whole, and so why not gather that data? Why not have the data at our fingertips in regard to what effects any changes within the drilling system have on the drill bit? So. Moving on, getting into a couple of case studies, and then open it up to questions. So new cutter and advanced testing. Again, like I said, the cutter testing and cutter feedback loop for our vendors has been a really critical component, but also this has really accelerated our ability to perform and learn from each and every drill bit cutter test. So you may be familiar, but with cutters, they're always changing, like bit design, and we're always trying to advance and find the next latest, greatest technology. One thing this allows us to do, because we have this massive data set of every bit that we run, is we can come in and perform statistical analysis with this box and whisker chart over here at the right. One thing we were noticing is a very high degree of variation on the cutter on the left there. And while our salespeople and the customers were all really happy with the performance of this drill bit, it completed the interval every time, so on and so forth, footage, ROP, everything was acceptable. We saw this within the data. As we drilled down, the data told us there's a high degree of variation. And this appeared to be, so we did some further investigation and study, and it was led by what we were seeing here as, and we refer to as localized catastrophic failures. By understanding these, the trade-off curves with cutter design and looking at the failure mechanisms themselves through metallurgy and scanning electron microscopic data, we were able to quickly identify the exact root cause of that failure and identify the solution with those known trade-off curves of what would help us to alleviate this heavy spalling, or what we refer to as complete spalling that was being experienced on some of those cutters. So from one cutter transition, one cutter type to the next, we were able to reduce the diamond loss by 92.3% overall holistically in this one instance here. So again, it's about giving us vision, insight into that data, into what our drill bits are experiencing out there. Next, 9 7/8 North Louisiana Intermediate design. This case study is based more on feedback for our individual designers. So how do they use this data day in and day out? Every time we design a drill bit, we get a team of experts, just like any bit company would. We put them in a room to evaluate the data, but again, instead of just evaluating dulls, we're able to sift through literally hundreds of runs and look for those complex underlying relationships. Within this case study, we saw that there was a strong correlation between back rate and back rate transitions and wear rate that indicated Only a minor tweak in back rates appeared to be the optimal solution for moving forward. This was based on evaluation of running multiple designs within this application, and then again, looking at that correlation analysis. This resulted in a reduction of 60% diamond loss and a 23% increase in footage drilled within this application. And this is that Painesville, North Louisiana, and vertical application that's extremely challenging down there, if you're familiar with it. With that, that is all I had. We'll open it up for any other questions and discussions. Yes, sir.
How long have you been working on this, and how long did it actually take to get the machine working, I guess?
We assembled the unit in roughly late 2018, and we had it functional. We were beginning data acquisition by early 2019. Yeah. So we're right at, we've been collecting data for we're right at 2 years, but that was the data in 2018 was very sparse and very limited. The workflow was very tough. To be honest, that was one of the biggest challenges, is convincing the entire company that we were going to throw in and drop a bomb in the middle of our repair facility, which is, hey, look, we're going to put this nice, sophisticated, fancy machinery here and make every bit come through this process. So that was a little tough too, but now it's just a normal part of our process, and we made it so much quicker. We had to, in order to not disrupt that repair workflow.
So does the operator contact you and say, hey, I'm having issues, I want you to analyze this? Or, like you said, every single bit that goes out, you're putting through the machine and analyzing it, and then approaching them and saying, hey, looks like we're noticing this, you guys might try X, Y, Z? Or how is that working?
Both scenarios hold true. We have some customers that are very ingrained within this technology, and so much so that, like I said, it's literally pushed over as part of their internal databases. So, and with those customers, every meeting is, what does the AML data look like? What is it telling us? We have some customers, though, that have very little, in all honesty, that have very little interaction with it, but we're still using it on the backside. Those customers, are maybe less data oriented and not into that, numbers, and they just want the result. The end result is, a bit that drills deeper, cheaper, faster. That's all they care about. So we're just using it to help optimize that drill bit. So, and they
So
really.
it's not an additional service?
I can't get into that in too much detail. Yeah. But the dynamic in the situation is unique with our customer base, with each and every customer out there, as to how much they use it and how we deploy it, what levels of feedback we provide as well.
And assume you're only going to look at your bits. Like, so if they were using another person's bit for another section of the hole, you're not going to take that bit in and analyze that for them.
Correct, yeah.
Oh.
Trust me, our competitors do not want us scanning their bits. We don't want to scan their bits, so,
Right.
yes. No, only Tourx drill bits go through this process, yeah.
Is this system also informing your repair procedures? Like, the bit gets scanned and then it comes out with a list that says, we're gonna spin these cutters are scrap, they're coming out, or help you better classify reclaims, that kind of thing? Or is there a plan to do that in the future? It seems like that'd be easy to automate with the system.
Yeah, exactly, yeah. From a machine learning standpoint, that is a very interesting realm, and honestly, I can't really get into that right now, though, sorry, but yeah, it is, it's definitely something that the system is capable of. That just, I'm sorry, it gets into some kind of IP proprietary discussion, so.
It's all good.
Any other questions?
You do tours at your facility?
We do, yep, we'd be happy to have you.
And what about student sections, AADE student sections? I think OU already has one scheduled with you guys possibly?
They do, yeah, with us being right next door, the university is literally 10 minutes from us. We've done a lot of tours with them. COVID obviously shut that down, so it's been a little while, but yes, we'd be happy to host. We actually have I think he's the president of,
Yes,
yeah, Cameron?
yes.
Yeah, is working for us. So we've talked about him, and then as well as some of the other petroleum and mechanical engineering students coming through. But yes, if you have anybody you'd like to bring through, we're happy to tour, happy to show.
Perfect, I've got OSU, I think they'll want to, and then I work on the national board for all student sections. So is that your contact information that I pass along to them, or somebody else?
Yeah, give them mine. We can start there. Yeah, we have not, we do have a relationship with a couple of people on the data science side at OSU, but not on the mechanical or petroleum engineering. We'd be happy to host them. We don't hold against anybody. I'm an OU grad myself, but we have a lot
I'm
of.
OSU, so I
Yes,
told
we
them
have a lot of
the same
OSU grads, so
thing.
we're willing to host any university. Yeah. But yes, we'd be happy to, and for any of the rest of you, except any bid guys out there, I'll let you know.
Has this helped you improve the, I guess, economics of your bid, where you can like, where you can decide to use, say, deep leach cutters in highly prone spots and cheaper cutters in other spots?
Absolutely, yes. That is, from an internal perspective, is definitely something that's game changer within the business. Again, we're making decisions, like all of our people, whether it's within engineering, repair, sales, the guys ordering the bids, what cutters do they put in each bid, which design do I order? And this system allows us to just better arm them with the information to help make the most economically favorable decision in some perspectives, but with the focus on performance first. Obviously, we're not going to do anything that would sacrifice performance, but if we can maintain performance with a lower economic cutter, a lower price cutter, then why not? And so yes, that having that visibility into that avenue has definitely been a huge advantage to the technology. All right. Well, thank you all very much. If you have any other questions, please feel free to reach out.
Thank you.